Hi class, today we're going to look at 3.3 number 14. So we have this polynomial and we want to sketch it. So we're going to use a four-step process for doing that. End behavior, y-intercepts, zeros with their multiplicities, and test points. So first off, let's talk about end behavior. To know end behavior, we need to know the degree of the polynomial. So our polynomial here is x squared times x plus 2, so there's a little 1 there, x minus 4, a little 1 there. So then you add together those powers and we get degree of 4. Okay, so we have a fourth degree. Our leading coefficient is a positive 1, so it's not written there. So with degree 4 and leading coefficient 1, we know that the end behavior is going to be like that. So up and up. Okay? The y-intercept, so that was the first part there. The next part here, let's just put a little bullet here, is find the y-intercept. So if we make x equals 0, we can find the y-intercept. Okay, so we plug that in. So we get 0 squared time is 0, and 0 times anything is 0. So we get our y-intercept is 0, 0. Okay, then oh, that's kind of cool. The light's shining right on what we got to do. Um, so that was our y-intercept. Our zeros, we need to figure out where is this crossing the x-axis. So if we look back at our original equation, each factor corresponds to a 0. Okay, so first factor, x squared, set it equal to 0 and solve it. So we could square root both sides. So x is 0. Okay, then we have x plus 2, set it equal to 0. So we get negative 2 from that factor. Then we have x minus 4, set it equal to 0. So here are our zeros. X is 0, negative 2, and 4. Okay, then we need to know the multiplicities. So x of 0 was x squared, and x squared is a multiplicity of 2. X plus 2 had a multiplicity of 1. It's just multiplicity is how many times a factor shows up in the factored form. So x showed up twice, that's why it has a multiplicity of 2. X plus 2 showed up once, multiplicity of 1. X minus 4, again, and just a 1, so multiplicity of 1. So why do we want to know the multiplicities? Well, the multiplicities tell us what happens at the zeros. Okay, so if my multiplicity is 2, this is going to bounce or touch and turn. Okay, so we'll have something kind of like an x squared where it hits the 0 and comes back up. Then for a multiplicity of 1, it's going to cross at those points. Okay, so here we go. Oh, that sun's bright. Let's scooch this over here a little bit. Okay, get out of the sun. All right, so next we need to look at a test point. So between our zeros, let's just start sketching out what this might look like. Okay, we aren't really worried. Oh, It's off the page. We aren't really worried about the y-intercept and scaling it so much. We know we have a 0 for x. We have 1 for x. Oh, I'm sorry. We have -2. Let me start a new picture. So our zeros are at 2, at -2, and at +4. Okay? We know that we're coming from above because it's up, up. So something up here going to this point, something up here leaving this point. Now at 0, we said it's going to bounce. So it's going to come down, bounce, come down, cross back up there. But the thing about this is that we don't know how far down to go in a couple of places. So we can test some points. So if x is equal to -1, for example, we're going to put that into our equation. Okay, so -1 squared is 1, -1 plus 2 is 1, -1 minus 4 is -5, so we're going down to -5. All right, so we're not really scaling this. Don't worry so much about it, but it go down to -5. And then come up here. And now this is where it's going to bounce. So it's going to touch and turn. Okay? And then we got to figure out what's happening at, say, x is +3. So f of 3 is 3 squared, 3 plus 2, 3 minus 4. So 9 times 5 times -1, -45. See, that goes down quite a ways. So we're not going to be able to put it all in the picture, but something like that. So now we have our graph. It's not perfect, but it's pretty darn close, and it should be plenty to give us an idea of what is happening with this polynomial. I hope this helped.